welcome to this web lecture about Windows system software. Obviously, we do not mean Microsoft Windows, but Windows system software in general that acts like a server, not a server for documents or files, but a server that offers graphical interface services. So an application, for instance, can request to the Windows server to open a new window. And the application will then say, oh, I want a window to have a top left corner that is positioned somewhere, and the window must be X number of pixels wide and Y number of pixels high. The server, as it happens with many services, can of course deny this request or only fulfill it partially. Maybe the window that is actually opened isn't as wide as we requested. You need to take into account that this can happen. The Windows system software, the server, hides the position of the windows from the application. So within an application, you can always use the window as if the top left corner has coordinate 0, 0. X is 0 and the Y, the vertical, is also 0. Some Windows systems offer also a facility that is called backing store, which means that the contents of the window is not only shown on the screen, but is also remembered off screen, so that when the window becomes obscured by another window and then becomes visible again, the contents can be retrieved from that memory and doesn't have to be recomputed by your application. Applications will use library functions to perform several graphical operations. For instance, to paint pixels or lines or ovals in a certain color on the screen, or to draw a rectangle or a circle. Also, when you want to show a string of letters on the screen, right, the windowing software will actually draw the strings in a font you can choose and in colors you can choose. You can also set the shape of the cursor. It may be an arrow, it may be an hourglass when you're waiting for something to happen, it may be a hand to show a position where you can click. This is all done by the Windows system, but you do not have to draw this cursor in your application program. You can also change the size and the position of the window, and you can also put windows on top of each other, as we will show later, and you can bring windows to the front or send them to the back. When an application wants to draw, say, a string or a rectangle, there are different ways in which this function can be performed. The application can use a library function call to perform the operation itself inside the application. But it can also give commands to the Windows system software to perform the operation. And often the application programmer doesn't even know whether the library function performs the operation in the user's application or whether it is performed inside the Windows server. The Windows system server itself may again decide to either perform the operation inside the server or to delegate the work to the graphical display system. In many cases, this special piece of hardware can perform graphical operations faster than the main CPU. There is also the issue of focus. When we are typing, the keyboard input has to be sent to the right application. Keyboard focus is what decides this. The application itself also has to decide to which of the input fields, if there are several, the input actually goes. This also includes moving the keyboard focus to different input fields when the user presses the tab key. On many web forums, we see that designers often forget to indicate what the next field is And when you press the tab key, the cursor just moves randomly between input fields. Mouse focus means which application actually tracks the mouse movement, gets button presses, and if you use the scroll wheel on a mouse, which window will actually scroll. Also, when you move the mouse pointer over different windows, each application may decide to change the mouse pointer into a different shape. When we use touchscreens, then we have to disambiguate the taps, the swipes, and the dragging motions. It is quite tricky to decide when the user touches the screen whether this is actually the equivalent of pressing a key on a keyboard or whether this is the beginning of a swiping motion. And sometimes when you use a mobile phone, you will see that the disambiguation does the wrong thing, and while you try to swipe, it is interpreted as a click. We now show a screencast to illustrate keyboard and mouse focus. The Windows systems all offer toolkits, or what we call widget sets. Widget means window gadget, which are objects with compound behavior. They do several different things at the same time. For instance, when you see a button, it first of all shows a label. There are other objects that are just a label with no button functionality. But so the button shows a textual or a graphical label, and it adds something that looks like a 3D border. The impression of a 3D border is generated by pretending that there is a light source, a lamp, in the left top corner of the screen, and it casts a shadow. Now, when you press the button, if this were a real button press, the shadow would move, and it would actually initially be on the right and the bottom side, and when you click the button, it would move to the top and the left side. And that gives you an illusion, right, of actually pressing a button. So the shading changes when you press a button, just like the shading on the borders of the windows give you the illusion of windows being on top of each other. And when you now press the button, a callback function is called so that the button actually causes some action to be performed. Window toolkits and Windows systems have additional features like double buffering. When you want to do an animation or show a slideshow, then it is best to first compute what you want to show in memory and then copy that to what is called the frame buffer so that the end user doesn't actually see how the image is being constructed. We will show an example of this in a separate web lecture. Functions thus draw off-screen what is copied to the screen. And this, when you do this, for instance, in a slideshow, avoids an effect that is flickering. When we design an application, we need to place buttons and other widgets somewhere inside the window. You can use fixed positions, but that means that you are already assuming a fixed window size so that when you place a button, it will actually be visible. If the Windows system decides to give you a smaller window, you may actually be drawing buttons that the end user cannot see. To avoid this problem, we use layout managers. They position elements, widgets, automatically depending on the window shape and following a certain algorithm. Here we see an example of the 4 main layout managers in the Swing toolkit for Java. The top left shows the border layout, where you have 5 positions to place elements: top, bottom, left, right, and center. Next to it is the grid layout, which places items of the same size in a rectangular matrix. More flexible, the bottom left, is the grid bag layout. It is like the grid layout, but you can have elements that span multiple rows and columns. Finally, there is the flow layout, which essentially works the way you wrap text around to the next line when you're typesetting a paragraph of text. But the flow layout does this with widgets like buttons. When you're using a mobile device, there is an additional challenge that the mobile can be used in portrait mode or in landscape mode. And what you see now, for instance, is that the home screen of my mobile phone isn't changing. But when you design your own application, it needs to redraw everything and redo the layout to adapt itself to the different orientation of the screen. Here we see a screen dump of some random windows shown on my computer screen, where we can see the visual effect of almost 3D. You see that some windows lay on top of other windows, and there is a sense of depth, but the depth here isn't real. We call this a 2.5D layered architecture. In the 2.5D, you do see that there is depth. Windows do lay on top of each other, and menus again and buttons lay on top of the window. But there is no real depth. You can't say how much deeper something is. Now, every window consists of a frame. On top of the frame, there is a drawing panel with the buttons and the menus that are again on top of that. So within an application, there is already an illusion of depth. Backing store can be used by the Windows system to redraw the contents of obscured objects without asking the application to do so. So when you, for instance, have a pop-up dialog box appear in your application and the dialog is completed, the system can redraw the window that was underneath. The application does not have to compute that. Now, these button presses and keyboard input and mouse movement all are called events. The Windows system must determine for every event, first of all, which application receives this event. That's what we saw in the issue of focus. Now, when the application receives the event, it needs to send it to the appropriate widget. Now, what happens is that depending on the coordinate of the mouse pointer in case of mouse input, depending on the keyboard focus being assigned to a certain text field, the application will send the event to the topmost, so the most forward widget that exists at that location. Now, that widget may decide to ignore the event. For instance, when we see a menu, it may have items that are grayed out. The grayed out menu items receive the event of a user clicking on them, but they ignore it. What then happens is that the event is sent down this stack of widgets. And so when a menu item ignores the event is sent to the menu itself, which lies underneath. The menu itself, when it receives an event, it knows the user clicked on a grayed out item. Doesn't matter which item, it just means, okay, the user did not click on a real item, I can now close the menu. So the Windows system and the application transfers the event backwards, right, until some widget is found that will handle the event. Part of this process is also the problem of making sure that the system is always ready to listen to events. That we will cover in a different web lecture. Thank you for participating.